10 would be a concern of things that are on the screen right now. And probably number 1 was a bit of a concern.
On number 11, shouldn't it be negative 6 instead of negative 5?
6 minus 5. Yes, it should. That should be negative 6 and positive 5. Nice catch, Louis. Nobody wants to see any of those? Everybody's happy? Everybody understands them? Lovely. What about 12 through 18? (16, 17, and 18) I imagine caused a bit of trouble if you are working along on your own. I'm willing to explain any one of them. (17), of course I can. So when you are faced with 17, it is similar to 16 because you will notice that what math is happening right there? Multiply. So two things are being multiplied together, yes? If that is multiplying by that, they are both factors, aren't they? And what math is happening there? Multiply. So they're both factors, right? So if I gave you this, 6xy plus 4y, you would remove the y, correct? By dividing it out, right? Because that is 6x times y, yeah? Now look, 6x times something, and then 6x times the same thing. So I can make them both their own letter, right? So if I rewrote this as 6xy, right, then I factor the y out, correct? So the y moves to the front, y, and I'm left with 6x plus 4, right? 6x, because the y's cancel, I got 6x plus 4. Cool to there, Ayla? Now, y was 2x minus 1, right? And then 6x plus 4. If you stop there, I'd give you 3 out of 4. Because that can be factored, can't it? 2 can come out of there. So the best answer to get the full marks would be 2x minus 1, 3x plus 2, and then this 2 out here. That's the best possible answer you could give me. Pardon me? Where you put the 2? No, because it's just multiplying. 2 times 2x times 3x, same as if it were in the middle, same as if it were at the end.
And it doesn't matter like the brackets and stuff. Like if they're like 3x plus 2 was where 2x minus 1 is. Like does that matter?
No.
Okay.
The only thing that matters is if the positive and the negatives are with the right constants. Now this question, 18, causes a lot of trouble because all of you by now are starting to see the substitution trick, right? Because you see that x plus 3 is the same as x plus 3. 2x minus 1 is the same as 2x minus 1. But what's slightly different in 18? They're flipped. This has a positive x and a negative 1. So what you do to fix this is you divide that by negative 1. Because negative 1 is a factor of everything, isn't it? Right? So if I divide that by negative 1, a negative 1 comes out to the front, and I get 3x minus 1. This negative 1 makes that x negative, and 1 divided by negative 1 is negative 1, and negative x divided by negative 1 is positive x, and now you see they're exactly the same. So what you get to do is bring that out, x minus 1, and what was left over? 3 minus x. Now, I have given you guys all these shortcuts Because we spent so long with GCF, right? Because you are all good at GCF, that's why you're allowed to do these shortcuts. If you weren't good at GCF, we would have to expand all this, collect our like terms, and then factor the resulting polynomial. And that takes a long time. But because you're good at GCF, it's easy for me to show you 3a minus xa. You see that a are in both of them. So the a comes out, 3 minus x. But a is x minus 1. Okay? That's why that works. And I have showed you that in the past, but my morning class needed to see that again, because here we are in the last day, and some of them were saying, where does the a come from? Everybody understands why I'm doing that, right? It's just substitution, just like x is some unknown number. Well, a is that unknown number minus 1. It's the same thing. Everybody good? All right. Anybody want to talk about 136? It looks like we went over 136. Oh, that was the page that Deweydoff had. Is everybody okay with it? Because there's infinite answers, right? You just have to notice the pattern. They had to be one apart from each other here, right? And whatever that multiplied to would work. Negative 12, negative 30, negative 42. It wouldn't matter. Because as long as it was 6 and 7, as long as they were one apart from each other, they'd add together to make 1, right? In this one, they had to be 2 apart from each other to add together to make negative 2, right? And in this one, because that's negative, I needed the bigger number to be the negative. And then this was just subtraction. The area of the blue is right there. Oops, that's the answer. Sorry. The area of the blue is right there. The area of the red is right there. Then you just subtracted them. 15 minus 2, 13 minus 10, and negative 20 minus 12. It's just subtraction. That was one of the things Deweydoff did. This was the other page Deweydoff did, where he showed you guys his way of factoring, and then I showed you my way of factoring. And then I allowed you to make your choice. My concern with this page, not that page, dummy head, this page, is that Mr. Deweydoff's way and my way are now commingling in your head, and you're not sure of which one to use. The only way to break that is to practice using them both until you decide which one you're more comfortable with. But you have to do that practice because you have to decide which one you like better. I know which one I prefer to use. I like my way. That's why I found out. Or that's why I researched a new way to find it, new way to factor them, found that way, and have kept that way for now 10 years. I never use Mr. Deweydoff's way, ever. In grade 10. In grade 11 and 12, Mr. Deweydoff's way can be helpful. But for everything you guys are going to face, I like my way better. But that's up to you to decide which one works better for you. Now, you have not seen the right answers to 3, 4, 5, 6, 7, 8 on this page. Because that, I believe, is what Mr. Deweydoff assigned to you. Yes? Am I right? So you need to see these right answers. Right? Now, if you've done this, I should be able to say, give me an answer, because you can check them, can't you? Right? There's no reason to have a wrong answer here. Because you check it, and if it doesn't multiply out to the original question, then you've done it wrong, and you wouldn't say that answer, would you? So, number 3, number 5, have a first step that you need to do before you can do either my method or Mr. Duidoff's. What is that first step? I got to do a GCF there, don't I? So I take a 3 out of there, and I get 3, 2x squared minus 7x plus 3. Now I can factor that part with whomever's method I like. I can use mine, or I can use Mr. Duidoff's. Number 5, you had to take out a 4. And you were left with 6h squared minus 5h minus 6. And then you would factor that, choosing whomever's method you liked. Otherwise, the other 4 on this page are normal. Would anybody like to offer an answer to any one of them? Because again, you can check. Check it right now before you say it out loud. Did your answer work? If it did, say it out loud. How do you check if it worked? Of course, you check the first and the last. Because if the first and the last work, the middle works. Carl.
I didn't do GCF right away.
If you don't do GCF right away, you will still get there, but you'll end up in this spot. You will end up like this. You'll end up with something that you need to factor and pull it out at the end. And when you tell me what you wrote, I'll tell you what I mean.
I wrote 2x minus 3 and 3x minus 3.
2x minus 3 and 3x minus 3, right?
Yep.
Okay. Notice right there I have a 3 and a 3.
So I have to factor to that side.
Yeah, you would factor that out, which you're allowed to do. You can do it that way if you wish.
I did.
So then you would end up with 2x minus 3. You take the 3 out of there, so that's x minus 1, and there's a 3 out front.
Okay.
Now notice that when that 3 out front shows up, watch what'll happen. This part right here, 2x times x, 2x squared. Negative 3 times negative 1, positive 3. This gets me this, and then this gets me this. Understand? Now, if I were marking that question on the 4-point scale, and you left me here, that's a 3. That's a good, solid understanding of factoring. It doesn't exceed my expectations. Because my expectations are, sure, you run that through your formula, whatever you do. Right? That's my expectation. I've shown you how to factor a trinomial. To exceed that, you should notice that, oh, there's a GCF there. Good? Same thing would happen with 5. Now, 5 is a better example because if you just follow my steps, you got to do 24 times 24 and start factoring it. That's an idiotically large number, isn't it? That's your hint. If you just follow steps, multiply A by C, danger, Will Robinson, then Geek Check, anyone? Anyone? Lost in Space, great show on Netflix right now. Crap show from the 60s. Crap movie from 1998. But for some reason, great TV show now. Nothing? Okay. Filmed in Vancouver. In case anyone cares. You wouldn't want to factor 24. So if you end up with a really gigantic number out there, chances are you could have GCF'd if you didn't see it immediately in the first place. Anybody get an answer for 4? Check it right now and tell me what you got. No one? Hit me, Corey.
4p minus 1 and 2p plus 5.
Absolutely right. 4 times 2 is 8p squared. Negative 1 times positive 5 is negative 5. If the ends work, the middle works. Sweet. Anyone got an answer for 5?
Wait, I have a question.
Sure.
If I had 2p minus 5 and 4p plus 1.
Okay. That won't work if you have the plus 1 here and the minus 5 there, because that means you had, when you expand it, you're going to get 8p squared minus 20p. Oh no, that would work. That was right. That's right. Corey did it wrong. Because you had minus 1 and plus 5, right?
Yeah. Oh wait. Yeah.
It's got to be plus 1 minus 5. Because what you had, Corey, was 4p minus 1 and 2p plus 5, right?
Yeah.
4 times 2 is 8p squared. 4 times 5 is positive 20, right? 1 times 2 is negative 2. 20 minus 2 is positive 18. What did you need? Negative 18, right? But this is a good question, actually. I want to do this question all the way through because of that. So whoever method you use, I'm going to use mine. I had to multiply to negative 40 and add to negative 18, right? Whoever method you use, that's your first step. You're either going to split that like Mr. Dewey-Dop did, or you're going to use my move. So to get to negative 18, you know it has to be 20 and 2. This is why I always write, when I decide my pair, I always write it down, because I need to get that pair to get me to negative 18. So the 20 had to be the negative one, right? So if you did Dewey-Dop's version, it was 8p squared minus 20p plus 2p minus 5. Or you do my version, p minus 20 over 8, p plus 2 over 8. Then you simplify your fractions. And the 1 got the plus. Okay?
Can we go over the stuff we did yesterday?
The stuff we did yesterday was just what I just did.
No, page 139. Or are we doing that today?
Whoa, 139 is this stuff. Yeah,
Okay.
right here. There's these 15 questions, and then I gave you 10 more to go from the B to the A, right? Now, did I put 3 difference of squares ones down here? Like 1 over 16 minus x minus 2 squared or something like that? Did I write those?
I think it's highlighted
This. Did I show you? Did I have these guys at the bottom for you?
No.
Those 3. I didn't? Okay. We'll do them in a minute. Okay, so there are the right answers. The first 6 are worked through. I'll highlight the actual answers. There, and there. And then the rest I don't have the work for it because my morning class, like only 3 people did it. So
Can you go over 9?
9. Yep. 9 bothers people because of that extra M.
Yeah, I just don't know.
Okay, I'm gonna show you. I'm gonna show you that because you people need to learn confidence. If that M's not there, could you do that? You could. And you would end up with something N plus or minus a number and something N plus or minus a number, right? Well, the N and the N make the N squared. Well, what would make the M squared? An M and an M, right? So you just need to add an M to the second number. That's the only difference. Okay? Let me show you what I mean, Ayla, just to prove to you that you actually know exactly what you're doing. X squared plus 7x plus 12. No first number, so I know I'm multiplying to 12 and adding to 7, right? What is it? Is it 1 and 12?
No.
2 and 6?
Yeah. No.
3 and 4?
Yeah.
Okay, so it's x plus 3 and x plus 4, right?
Yeah.
Okay, now, xy and y squared. What would make 3 times 4 get me 12y squared? It would need to be y, and you'd have the answer. That's the only difference. I know, but you're not, everybody asks about number. Oh, what do I do with the extra letter? But you know what to do when it's a squared. You need 2 letters.
Yeah.
So here's the squared again, so you need 2 letters. That's it. Anything else from this page? I erased that answer now, but it was there before. What? 6, yes. Okay, 6 is another good one because there's 2 ways to do it. I personally, I can factor that. You guys like to see stuff looking the way you're used to seeing it. You like to see the y squared at the front. So you would change this order, and you'd write negative 2y, because it's negative, right? Then you like the y in the middle, so negative 7y, and you like the number at the end, and it's positive. But you don't like having a negative there to factor. So I take out a negative 1. Negative 1 comes out, and what does that do to all these signs? Changes them to the opposite. And then you just factor that normally. Now, one kid in my other class left it this way and factored it this way, which is fine. You're going to end up with the same answer. The point that I'm trying to make is much like 5 times 2 is 10 and 2 times 5 is 10, order doesn't matter. If whatever you write down as an answer expands out in some way to the original question, you're going to get the bulk of the marks available to you. Do you understand what I am saying? Anybody want to talk about anything else there on 1 to 9?
Number 8.
Number 8? Yep. I'm sorry, what, the answer to 6?
Yeah.
See if I can get it back. What do you mean the majority of the test? Factoring? It's a whole test on factoring. I don't have the answer anymore. Oh, wait, yeah, I do. I have it in another book. There it is. Okay. Somebody asked about, Louis, I think, just asked about a number. I think Louis just asked about 8. Except 8 is exactly the same as if that y wasn't there, right?
Yeah.
So if that y wasn't there, you would factor it to get this, 2x minus 1 and x minus 2. But you need a y there to make that y squared. So it becomes 1y. We never write the 1, so it becomes y and 2y.
Wait, does that say x minus 7y?
No, it says 2y.
Oh, I got it right then.
My 7s have crosses. That's why I draw my 7s that way, so you don't ever make that mistake.
Okay.
Yeah?
Yeah.
Number 9 has disappeared because of the m, but that's just because what we were talking about. We know how to do it. There is 10 through 15. Noticing, of course, here, 6, 66, and 30. all divide by 6. So I took out the 6. In this one, x, 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 so I took out an x. In this one, e squared, so I need an e at the end. And in this one, b squared, so I need a b at the end. Teaching this unit is very difficult from a math teacher's perspective because you people do not speak. You sit there and stare at the screen and you stare at me and I'm supposed to read your minds. And then after I give the test, people come back, well, I didn't know how to do it. And I say, sorry, my mind reading is bad. Because of course it's impossible. That is why I gave you 50,000 practice questions. Because this is literally just like the way you should have learned your times tables. That is the only way to learn how to factor, is practice it.
Are we going to go over the extra ones?
Yes. But first, I want you to try those 3 because I didn't give you any of these difference of squares ones. So try those 3 right at the bottom of 139 there, if you don't mind. Rugby guys, you will be leaving in 5 minutes, but I would highly recommend sticking around at least for these 3. The bus isn't going to leave without you. And even if it does, you could walk to Yale by the time the game starts because of this idiotic decision of busing in our district. Needing a 12:10 early dismissal to get to a game at Yale.
Any of those pens would work.
There are 2 ways to do number 16. There are 2 ways to do number 17. One is easy, but requires you to understand what is going on. One is very easy to do, but requires a lot more steps. It is up to you to decide which one you wish to use. And number 18, there is no trick to it. It's just fractions. And I know fractions make most of you run screaming for the hills, but there is no need for that. Fractions are your friend. They even start with the same phoneme. What's a phoneme? A sound. Fra. Remember, if you have a difference of squares, and I'll remind you of it right over here, x squared minus 4, that is the square root of that one and the square root of that one. Plus, minus. Square root of x squared is x, square root of 4 is 2. Square root of x squared is x, square root of 4 is 2. Done. Anytime you have a square minus a square. Now, do I have a square minus a square? Does 4 have a square root? What is it? 2. Does x have a square root? X squared have a square root? What is it? X. Plus, does 36 have a square root? What is it? 6. Does y squared have a square root? What is it? Y. And then I write it again the exact same way, except there's a minus between it. Now, if you got to there, you are at a competent level of factoring. How do you get the extra level of factoring? What do you notice about 6, 2, 6, 2, and 6? You can simplify it, right? What comes out of here? 2. So what would go to the front? 2. And I'd be left with x plus 3y, correct? What comes out of here? 2. So what goes to the front? 2. What am I left with? x minus 3y. What do I do with 2 and 2? Multiply it together to get 4x plus 3y, x minus 3y. Yeah? Yeah. Now, come to here. 17 looks different. Two things bother you about 17. One, the fraction bothers you, but it shouldn't. Because if it was 16, what would the square root of 16 be? 4. So what would the square root of 1 over 16 be? 1 over 4. So the fraction shouldn't bother you, but this should bother you because it's ugly, right? When it's ugly, what do we do with it? We change it to make it pretty. What's prettier? This or 1 over 16 minus a squared? That's a lot prettier to me. Square root of the first one, 1/4, plus the square root of the second one. What's square root of a squared? A. Then 1/4 minus a, correct? But what's a? X plus 2. So this is really 1/4 plus x plus 2, right? And what's this really? 1/4 minus x. And what's or x plus 2 is minus 2, right? Now, what do you do with like terms? Collect them. What's 2 plus 1/4? This is not a trick. 2 1/4. So that is x plus 2 1/4, right? Right? What is negative 2 plus 1/4? That's the same as 2 minus 1/4, isn't it? If I have $2 and I take away a quarter, what do I have? $1 and 3/4. So this is negative x minus 1 3/4. And now that one's done. Right? Everybody understand? Okay. And then this one, if it was 4x and 9y, it would be 2x plus 3y, wouldn't it? If it was 9x and 16y, it would be 3x and 4y, wouldn't it? Right? Okay, so that must mean it's 2/3 x plus 3/4 y, and then what? Same thing, except it's minus. And now it's done. Rugby guys, go. Good luck. Hopefully you'll get there on time. It's going to be close. I hope you have enough time to warm up so you don't pull any muscles. 3:30? I know. Don't get me started.
I think we should give it some higher start. I'm curious now.
No, because this is recording. Is everybody good? Please, please, please understand, if you can do the easiest, simplest one, which is x squared minus 1, you can do every one. If you can do the easiest trinomial, x squared plus 2x plus 1, you can do every single one. Stop looking at every question like it's something new. Don't look at what's different. Look at what's exactly the same. Right? Right? Here are the crazy hard ones. All the answers are there already. I do not know if you need to see them, but they are all highlighted. I even put a trick one in there with number 3. Have a look. I didn't do the answers to 9 and 10 because it's just expansion. Pardon me? The expansion. Yeah, but see, that's what gets me, Ash. Factoring is no different, right? Like, it's just reversing it. If you know how to distribute this out, then you just got to work backwards. Now, of course, I do not mind actually working through any or all of these. You just have to ask me. You can't sit there like this.
Do you not have a review?
And this is the review. The whole.
You're not gonna take one?
No, I'm not going to take marks because for you guys, we had the Mr. Duidoff me situation, and for my morning class, none of them did it. So I'm tired of giving zeros, and I'm just tired of it. Right? Or worse, I give a 0 and then the person comes in the next day with it miraculously done perfectly. Oh, I had it done all along. Then I give them their 100%, and then on the test, which have a bunch of the exact same question, they get none of them right. Right? And too many of you people think that I'm too stupid to catch that. Like, you think that I honestly believe yesterday you could do it 100%, and the next day with the same numbers, you can't? Like, what kind of horse crap is that? Right? That's like saying, I played soccer for 12 years of my life, and I go out tomorrow, and all of a sudden I pick up the ball with my hands and run because I forgot. It's a load of horse crap. And it's embarrassing that you people try to do that, but you don't care. You don't care how bad it makes you look when you pull crap like that. I don't know why. I don't have that low level of integrity. But too many of you people do. And I'm not pointing at any one of you in particular in this room. I'm saying that this is the type of crap you guys try to pull every day in school. And we let it go. I don't know why we let it go. Because it doesn't work in real life. A heart surgeon can't go into work and say, yeah, I just finished 8 years of heart surgery school. I'm cutting into my first guy. I'll not do it. Right? It doesn't happen. But here we allow it to happen. We encourage it. I don't know why. I'm one man fighting against the world. So the short answer to your question, no review.
Okay.
And yet here I am. Does anybody need me to go over them? And not one person is... Thank you, Harnar. What one? 8? No problemo. Let's have a look at 8. I'm going to write it bigger over here to make it easier to deal with. 4x plus 7 squared minus x plus 2 squared. Now, if I gave you this, x, no, I don't want to use x because I've got x's all over the place. If I gave you y squared minus 16, what would you do? You'd square root the first one and get y. Then you would add the square root of the second one, which is 4. And then you'd write it again with a minus between them, right? Okay, now, what if I gave you this? Y squared minus b squared. Is that a square and a square? So what would you do with the first one? Square root it to get y, plus what would you do with the second one? Square root it to get b, correct? And then what would you write? Y minus b, correct? Okay, look at this. Do I have something squared there? Did I have something squared there? Okay. Do I have something there? Is it squared? So isn't this the exact same as this? So one thing I can do is I can change this to a and b, right? So this is a squared minus b squared. Square root of the first one, a, plus b. Square root of the second one, a minus b. What's a? 4x plus 7. 4x plus 7. Right? Plus, what's b? X plus 2. Then, a, 4x plus 7, minus, what's b? X plus 2. What is 4x plus 1x? 5x. What is 7 plus 7 plus 2? 9. What is 4x minus 1x? 3x. What is 7 minus 2? Plus 5. And it's done. Please understand, right? There's no tricks here. I'm not doing this to mess with your heads. If you can do this, then you can do everything that is squared minus squared, no matter what it is. But you need to know that. You need to be able to make this, all these connections. And that's my job, to show you these connections, which I've showed you numerous times, yes? So what is the only way to get better at it? Use it, right? I can show you a toaster 1,000,000 times. But for you to make your own toast requires you to learn how to use the toaster. I personally, on my toaster at home, like the dial to be at 6. But at your toaster at home, 6 might send me out a charcoal briquette of toast. Right? So when I try it the first time and turn it to 6 and I get a piece of crap piece of toast, what am I going to do the next time? I know that the dial makes it darker or lighter, so the next time I'm going to turn it down. I don't walk up to the next toaster and go, I guess I'm not having toast today. Do I? Because it works the same. Put the toast in, push the button down. Right? Same thing. If you can do one, you can do all of them. But the only way you can do them is to practice. And the only way I can help you is if you tell me where in this continuum of knowledge you are stuck. What part of this, going from that, which you can do in your head in 2 seconds, to this, is where you're lost. Because I don't know where you're lost. Because I see this as being perfectly logical. This just flows for me. If it works here, it works here. Part of that is practice, and part of it is because that's the way I learn how to do things. I take something easy and I apply it and apply it and apply it and apply it until I have where I need to be. Anything else from this page? I'm surprised no one has asked about number 7, quite frankly. Number 7 is a very similar case. 2x9 minus 512x. What are some hints there for stuff you can do? Because maybe you don't know what the final answer is going to look like, but you know that's not right. So give me something you can do with that. Because, I mean, you can see it, what I did, but give me something you could do with that now. If I erase this all, because I know nobody's got it memorized.
Get rid of the 1 square for sure.
You can get rid of
The 1 square for sure.
which square?
The square is, you can simplify this.
You could simplify. So I can take out what? I can take out 2x from both, can't I? Because 2, and that's even. So out's going to come a 2. That guy's got 1x, that guy's got 9x. So I can take out a 2x, correct? So that takes me to 2x, x to the what? 8 minus 256. Now, does that look like something you have seen? It looks a lot like a difference of squares, doesn't it? Because that is an even number. So again, if I know how to do x squared minus 1, square root that, plus and minus, then I know how to do this, don't I? What is the square root of x to the 8th? X to the 4th. Plus, what's the square root of 256? 16. X to the 4th minus 16. Now I look at that. Does that look familiar? Why? Because it's a difference of squares. Square root the first one, what is it? X squared plus 4. Square root the second one. X squared minus 4. Now what does that give me? Another difference of squares. Why? Because x squared has a square root and 4 has a square root. Sooner or later it'll show up. There we go. 2x. X fourth plus 16. X squared plus 4. X plus 2 and x minus 2. And am I done now? Yes. How do I check if it's right? X to the 4th times x. X to the 6th times x. 1, x to the 7th. x1, x to the 8th. 16 times 4 is 64. Times 2 is 128. Times 2 is 256. All that times 2, 512. The problem that all of you have in the 10th grade, and it's not just this class, it's all of you, you do not see this as a progression to this. You see this and think there is some miraculous way to get to here. You see that and it scares you. And it's the same analogy I use all the time. If I told you tomorrow that we are going to walk to Chilliwack, you all would be concerned with the fact that you had to walk 36 kilometers. But really, all you're doing is walking one step 36,000 times. Will you get to Chilliwack? Yes. If I told you today you had to do 500 push-ups, every one of you would be like, no way. But if we did 5 push-ups 50 times or 100 times, would we have done 500 push-ups today? Would it have been easy? Could every single one of us have done it? Yes. Could any one of us do 500 in a row? No. Understand? Stop looking at the ends and start realizing that the middle is where the math is happening. And that's what you already know. It sounds so stupid, I hate even saying it, but you have to believe in yourself. For some strange reason, all of you believe in yourself for everything else except math. And I don't get it. I watch kids in this school playing minor hockey, honestly believing they're going to go to the NHL. I watch kids in this school playing in the band, honestly thinking they are going to make a living playing an instrument because they believe in themselves. But when I ask them to believe in themselves with math, no, can't possibly. Telling you, learning to play the trombone is of a lot harder than learning to do math. Learning to drive is of a lot harder than learning to do math. Learning to ride a bike is of a lot harder than learning to do math. And every single one of you is able to do all those things. Why? Because you got back onto the bike. Why? Because you got back in the car after you stalled it 7,000 times and did the bunny hop while you're trying to learn to drive a standard. You got back in and you tried again, and it became easy. But I ask you to do that in math? No, can't possibly. No way. I'll never do it. And you give up, and I don't get it.
Can I see the 9?
Yes. You want to see me go through 9? The expansion? Because I didn't do it. There's no answer written there. Okay. I expand that 3 times. 2x cubed minus 6x squared plus 8x. Do you understand that? Okay. Then you just do it again. 7x squared. I'm going to put my x squareds with my x squareds so I remember to gather them up later. 7 times 3, negative 21x. 7 times 4, plus 28. Then I just add it up. 2x cubed plus nothing, 2x cubed. Negative 6 plus 7 is positive 1x squared. 8 minus 21 is negative 13x. And 0 plus 28 is positive 28. And I hope you are all not reading into my tone a belief that you cannot do this. The reason I've done this horrible motivational speech crap thing when you believe in yourself is because I believe that you can do this. If I didn't, I would have quit. Do you think I am the kind of person that would do the same thing over and 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 expect different results? No, because that's crazy. I continue to come back here because I believe all of you can handle this all the time. And I want you to have the confidence to do it. Okay? This one, Carl, I expanded this is x plus 2 thrice. So I expanded 2 of them to make this trinomial, and then I'm just in the same boat as here. Then I just run it through again. But that's what I mean. If you had to say something that I say most often in this room, one thing that always comes up when I ask kids that, you always say, Mr. Miles, if it happens once in math, it happens every time. It's true. If you can do any question I give you once, you can do every question that I ever give you. Trust me. Just try it. What do you have to lose? If you don't try it, you're guaranteed to lose. If you do try it, maybe you get it and maybe you win. But not trying is guaranteed to lose. Anybody want to see anything more? It's 12:37. I could get you a couple of the fun puzzle sheets that aren't in your book. And you could practice factoring. And you would get a good joke. Yeah. I know my good friend Bryce